Our ordered pairs are, here's the y-axis, the x-axis is over here off the screen, but I'll put it on a bit later when we have more space. -1, -3, -1, 1 to the left, down 3, 0, -1, 0 sideways, and then down 1, and 1, 1, 1 to the right, and 1 up. So here's our equation, graphed as we did it just a few minutes ago. So here's the first equation. This one is y equals 2x minus 1. We already know how to solve the equation for the letter y, and so what I've done for this next one is just to do the solution and give you the result. When you solve this second equation, 4x minus 2y equals 6 for y, the equation becomes y equals 2x minus 3. Now I'm not showing you how this is done because we have done this several times before, and in the preceding example we went through all of the steps. If you have any trouble getting this form, you need to ask for help from the instructor or a tutor in the lab. So the new equation is y equals 2x minus 3. A table of values for that, which I've already worked out for you. -1, -5, 0, -3, and 1, -1. So the ordered pairs are -1, -5, 0, -3, and 1, -1. Now once again, if you have any trouble getting this table of values, you need to ask for help from one of the instructors or tutors. So let's take these ordered pairs and put them on the same graph we just were setting up. So here's our graph we just did, and let's carefully graph these ordered pairs. The first ordered pair is -1, -5. That means to the left 1 and down 5. 2, 3, 4, 5. To the left 1 and down 5. Next we have 0, -3, which means none sideways, and then down 3. 1, 2, 3. Then 1, -1, which means we go to the right 1 and down 1. Here our 3 points are. We put the ruler down and draw the line. So here the two lines are. Remember that the solution for a system of equations is the point or points of intersection. Where are the point or points of intersection? Do you see any? There are not any point or points of intersection. There are not any points of intersection. These two lines are parallel lines, and if you extend them forever, as the arrow points indicated, they still will not intersect. This means the solution to this system is no solution at all. There is no solution to this system. So our result on this is no solution. Let me make a note on this that the graph shows parallel lines. There is no solution, we get parallel lines. And the parallel lines never intersect. There is a name given to the system that has no solution. It is known as an inconsistent system. When the lines are parallel and there is no solution, the system is called inconsistent. We have a second special case. For our second special case, I'm going to use a system that's almost like the one we just did. The first equation is 2x minus y equals 1. Do you recognize that? This is the third time we've just used it. 2x minus y equals 1. And for the next equation, 4x minus 2y equals 2. This is almost the same as the second equation we just finished using. Now I'm choosing the same equation for the first one to save us time, and I'm going to take the same kind of shortcut that I did for the second one just a few moments ago. So for our first equation, 2x minus y equals 1, this becomes y equals 2x minus 1, and we have ordered pairs negative 1, negative 3, 0, negative 1, and 1, 1. So let's take a look at the graph for this one. Once again, here's the x-axis, here's the y-axis, and we have negative 1, negative 3, to the left 1 and down 3, 0, negative 1, none sideways and then down 1, and then 1, 1, to the right 1 and up 1. So here's our line. It's getting to be an old friend. So here's the graph of the equation y equals 2x minus 1. Now let's look at the other equation. 4x minus 2y equals 2. 4x minus 2y equals 2 becomes y equals 2x minus 1. Y equals 2x minus 1. Y equals 2x minus 1, that's what we just had. Let's double check that. 4x minus 2y equals 2. 4x minus 2y equals 2. We want to get y by itself, and so we'll subtract away the 4x. 4x subtract 2y minus 4x equals negative 4x plus 2. The 4x's cancel, leaving us with negative 2y equals negative 4x plus 2. Then we'll divide both sides by negative 2. And this gives us y equals negative 4x over negative 2 is 2x, and positive 2 over negative 2 is minus 1. So yes, that's right. 4x minus 2y equals 2 becomes the old familiar y equals 2x minus 1. That means that the table of values for 4x minus 2y equals 2 is exactly the same table of values for 2x minus y equals 1. The table of values we've just been using, this one. That means that when we graph the line, and we're to graph it on the same coordinate system, we'll graph the points negative 1, negative 3, which is here, 0, negative 1, which is here, 1, 1, which is here. We'll put our ruler down and draw the line, and the line will be drawn exactly on top of where it was to start with. And so we get another line right on top of the one that we had. Do these lines have any points in common? Do they intersect anywhere? Indeed they do. They intersect in all of the points that are on the line. Here, the points they have in common make an infinite set of points. There are infinitely many points that these lines have in common. The whole line full. How do we write the answer? There are different ways to write the answer. We need to make sure we understand that the solution is all ordered pairs that satisfy the equation y equals 2x minus 1. All ordered pairs that satisfy y equals 2x minus 1. You may find the solution indicated just this way. lots of words, all ordered pairs that satisfy y equals 2x minus 1. That is a perfectly correct way to write the answer.